Hi all, welcome to another blog of Infrastructure as a Code with Dell's platforms. In this particular blog, we're going to actually explore further use cases around Dell's PowerFlex system, which is a software-defined storage, in a separate blog, and I'll share it on the screen. I had highlighted the fact that how you can actually provision through Terraform n number of volumes and whatnot on a Dell PowerFlex array, which was actually hosted on premises. Now, in this particular blog, we're going to actually take a step ahead and extend the PowerFlex concept as a software-defined storage in the public cloud, which means that we're going to actually deal with an offering called as Apex Block over AWS. And this offering, the underlying technology is the same as the on-premises PowerFlex software-defined storage. So what's going to happen is basically in the AWS cloud, you have a set of EC2 instances which are aggregated and abstracted. On top of that, there is a PowerFlex software-defined storage running. And this offer is called as Apex Block over AWS. Okay. Now, what this block storage allows us to do is natively in the public cloud, you can run this as a block storage layer and then let your EC2 instances or EKS clusters consume this basically as a block storage layer. Now, I know, there are so many documents available in the public internet and through your Dell contact points, you would actually have access to them. Let's focus this particular blog on the fact that if we had the SDS, which is Apex Block over AWS, how we can use Terraform to not only provision the volumes in the on the platform, but also given an EC2 instance, which is a Ubuntu host, how we will actually automatically through Terraform mount that particular volume onto this EC2 instance, which is a software-defined client, like you have a iSCSI client or an NFS client. You have a software-defined client running as a Ubuntu host on an EC2 machine, talking to a Apex Block over AWS, which is nothing but the PowerFlex storage running inside of AWS. And then we will see this through the Terraform template and script execution. One thing to note is that whatever we are doing here is interchangeable, that if you were to deploy the same template with a few variable changes on the on-prem side of the world. So if you had a PowerFlex appliance running, you could do the same templating and run and do the same thing if you have a SDC running on premises connected to the PowerFlex array. You could really leverage the same thing and reuse it. So I just wanted to take this moment or exhibit to also showcase how Apex Block over AWS, given the fact that, in cloud, you want that kind of agility and, infrastructure as a code, running smoothly, we will demonstrate it here actually. So let me share my screen. You can see that this is my previous blog. And I had noted this Dell software infrastructure as a code, terraforming with PowerFlex 4.5, software-defined storage. And you could see it, I've mentioned it here, that Dell PowerFlex SDS can run on-prem or in public cloud as Dell Apex Block Storage, right? And in this particular blog, this is the previous blog, we had curtailed the blog to actually just creating the volumes only actually. So you could see that after giving the provider framework and the inputs, we created 4 volumes, and I'm not going to repeat this block again here. Okay. So the fact is, in this particular discussion, what we are planning to do is this. Like I said, we have the Dell PowerFlex storage, which is Apex Block Storage for AWS running inside of AWS. And then we have a Ubuntu EC2 based Ubuntu host, which is of the IP 172.26.2.33. Now, this is already connected through the SDC SDS connection over TCP IP to the block storage layer running inside of AWS. What we are focusing on is using Terraform to A, create the volume, B, whatever volume that gets created, mount it to the EC2 host actually. Okay, so that it can start consuming the volume maker. Okay, now let's go ahead and I will share my screen from the, So you can see that this is the console for my web GUI for my PowerFlex running inside of AWS. I'm not going to now use words interchangeably. I'm just going to focus on PowerFlex AWS, and you can actually leverage that term for Apex block over AWS, right? So they are interchangeable in that sense. So this is PowerFlex running inside of AWS. We can see that as of now, there is one client. Okay. And did I make a mistake by writing 33? Sorry about that. It's 123. You can see this, the host IP is 172.26.2.123. This is the SDC ID, which is a unique identifier PowerFlex uses to actually recognize its incoming host connections. Let's also see this from an EC2 basis. So you can see that these are the storage nodes running in which the PowerFlex software-defined storage is running upon. These are 3 EC2 instances. Small size storage pool for a demo purpose, but it's quite extensible. And this is the SDC, which is the SDC client. Let's look at the IP address. You can see that 172.26.2.123. Okay, and this is what I was trying to show it to you here. So allow me to actually do this change while we are talking. 123. Yeah. Okay. So you saw that we have these 4 instances running, the 3 instances which are the PowerFlex cluster, and the 4th one is the actual client which will consume the block storage from these cluster nodes. Okay. Now I will hop over to my So let's see what is there in this particular directory. So I have 2 files, which is the main.tf and the variables.tf here. Let's look into the main.tf, which is the main Terraform template here. As you can see, it starts with the usual declaration of the provider, with the provider being PowerFlex, version is 1.3.0. And then, like any regular Terraform configuration, typically, to connect to the PowerFlex, we are going to supply the username, the password, and the endpoint, which are declared in the variables.tf. Obviously, I'm not going to open that username password for you here, but it's just a variable input, and do it as per your system there, right? Next resource is the PowerFlex volume. So we are going to start deploying a volume first, which is going to be an 8 gig volume. The count is 1. Now, unlike the previous blog, which I showed, we actually created 4 volumes there. Okay, so the count index would automatically append itself. Here we just have 1 volume, so the count index will remain as 0. So 1 volume prefixed with Dell-AWS, the defaults in terms of production domain and storage pool name. And then we are going to thin provision this volume with a access mode of read-write. So you can have read-write, you could have read-only or no access type of volumes created. Here we are going to do a read-write. So once the volume gets created, to kind of alleviate any transition issues, we wait for 20 seconds. So this is the second resource, which is like a time sleep resource that Terraform provides. So wait for 20 seconds, and then we are going to actually create the SDC volume mapping here. Okay, which means to say that this is the ID of my SDC host. You would have seen this here. Hosts. So you can see 59, F89, FC, whatever, right? So This is the name, the ID of this. And then I'm using the hexadecimal part of that as the identifier here, okay? And then if I had multiple volumes created, I could map all of them. Here we are just creating one volume. So the volume list, you can see it's an array here. So the list would have just one volume right now. So volume name is Dell-AWS-0 because of the count index being 0 here. The access mode is read-write, IOPS. So you can specify multiple parameters there. I mean, you can always look up to the official documentation for the Terraform resources. There's plenty you can do out there. So let's keep it simple here. We're creating a volume. We're waiting for 20 seconds and then mounting it onto this particular SDC, which is a Ubuntu host running on EC2 instance. And then finally, for our convenience, we just output the volume ID here, okay? So enough said, let's go ahead, Terraform init, okay? Terraform plan, okay? And then finally, Terraform apply and auto approved. So what's going to happen is you can see that the volume has been created, or 3 to add. So you can see that volume creation is complete. It will wait for 20 seconds. 10 seconds have elapsed. So 10 more to go. Let's take a deep breath. And then once this is done, you can see the final resource, which is the mapping. So at this stage, the volume should have been created and the volume should have been mapped to the EC2 host, which will be a client for the block storage. So let's validate this. The volume ID also, okay, I just cleared it, but you can see here now, suddenly this count has changed from 0 to 1. So mapped volumes is 1 for this SDC. Let's first look at the volumes. So you can see a new volume has been created where there was 0 on this particular screen, as we saw previously. So new volume has been created and the host, number of hosts it's mapped to. So it's mapped to a single host and this host is the same SDC here. And you can see that the mapped volumes is 1. We can obviously, it's like going round. So you can see that with such ease, and we're talking about one host, one volume, but in a agile, enterprise where you have a massive cloud footprint and you are used to this infrastructure as a code being your primary vehicle to manage things, you can easily fit in, the Dell SDS from PowerFlex. And then whether on premises or in the cloud, doesn't matter. You can use Terraform to manage your resources, all throughout seamlessly, in a hybrid, true hybrid sense, actually. Now, this is done, but this is just saying that, okay, we have a volume and it's mapped to the host. We've verified this from a GUI perspective. Let's actually look into the host itself. So you can see that I am inside of this particular EC2 instance, and you would know the notation. You would know this is a typical AWS style. So root, I'm logged in as root. IP address is 172.26.2.123, which is nothing but this particular instance here running as 172.26.2.123. Now, if I just issue the command, you can see that this is the new volume, or this is the new volume presented as skinny A, okay? And if I had 2 volumes, it would be skinny B, skinny C, and so on, right? It's 8 gig volume that we just created. So let's just try mounting this particular volume. We'll have to, I'll just quickly, in the interest of time, I am going to just copy paste the commands, nothing else. Okay, so let's just make a directory here. and then format this particular volume. Okay. Let's just do that. Okay, so the file system has been created on /dev/skinny-a. Let's just mount this particular volume. I want to make sure that I don't do a typo, so I'll just copy paste. We'll do a temporary mount for now. Okay. So let's validate this mounting. So you can see that now the /dev/skinny-a and this directory has been mounted actually, right? Which is PowerFlex test. Okay, clear. Let's just create a couple of files here. txt. Okay. Let's unmount this particular, what we say, PowerFlex test. Okay. And let's remount this and see, validate if I can still access my files. cd PowerFlex test. Yes. Okay. So that practically brings us to the close of this video demonstration. I'll just quickly summarize what we have done here. You can see from this presentation that I was sharing, we have used Terraform to create the volume. We mapped the volume. We validated this particular, whatever we've done through Terraform on this Ubuntu host. So I hope that you enjoyed the practicality of this video. Thanks a lot. Cheers.